Alright, lesson 7.2a is solving linear systems by substitution. So we just talked about what substitute means, meaning, for example, you're taking one piece out and putting something else back in its place. Like if you order a burger, this is a hamburger with all your fixings on a plate, and you normally get fries. You have blue French fries. But let's say you don't want French fries, and instead you want tater tots. Well, they're going to take those tater tots off your plate and give you, take the French fries off your plate and give you tater tots. So we're substituting out the French fries with the tater tots. It's taking the place of one another. So here, we need to solve this, and anytime you see the letter y, we're going to replace it with a -9. So here, instead of y, I'm going to take out the y entirely, it's gone, and plug in a -9 in its place. So we're going to solve this just like we would a regular equation. The opposite of subtracting 9 would be adding 9. So those eliminate, and we have 2x equal to 9 plus 5, which is 14. And then last, the opposite of multiplying by 2 is dividing by 2. So 14 divided by 2 is 7. So what this means is that we have a point where x is 7 and y is -9. X and y. Now in 7.1 we learned that if you have two lines, wherever they cross, that's going to be your answer. And that's what we figured out without actually graphing these two equations. So that the point 7, -9, that's where our lines are going to cross. Maybe one line looked like this, and the other looked like that. We figured out, oh hey, our solution or our answer is going to be right here, if we have this equation and this equation to start with. So now let's try the same thing, but instead of y or x just being a number, we have y or x being an equation or a piece. So anytime I see x, I'm going to replace it with this whole piece, y plus 4. So I'm going to take out this x, and I'm going to plug in y plus 4 in its place. So I'm going to rewrite this. I have 2, and these are touching, so multiplied by y plus 4. Then it says plus 3y equal to 14. So I took out x, and I replaced it with y plus 4. Now I need to solve, and I can double check to make sure I have all the same letter now. Y, because eventually we're going to want to combine them together. So I see parentheses here, that means I'm going to distribute. I have 2, and then y plus 4. 2 times y is 2y. 2 times 4 is 8. So I have 2y plus 8 plus 3y equal to 14. I just rewrote what I already have. So now, one thing that you guys learned earlier is to combine our like terms. We have 2y and 3y, that gives us 5y, and then plus 8 equal to 14. And then just solve like a regular equation, get rid of addition and subtraction. We got 5y equal to 14, take away 8, gives us 6. And then last, we're going to divide by 5. So we have y equal to 6 divided by 5. Now, that's not a very nice number, so if you just type that in your calculator, as a decimal, it's 1.2. So this one, back here, we had a nice answer for x and y. This next one, it's okay that we don't have a very nice answer. We just know y is going to be a 1.2. So now we need to figure out x. If we know what y is, we can take it and plug it in to where we know y is. So I'm going to use the other part here that I have left over, and I have 2x. Oh, you guys, we have two equations. I don't want to do more work than I have to. Instead of plugging into this big equation, why don't I just plug it into this equation over here? you'll get the same answer no matter which equation you use once you already know what y is. So if I know x equals y plus 4, and y is really 1.2, like we learned down here, x is 1 plus 2, 1.2 plus 4. So 4 plus 1.2 is just 5.2. That's a lot more work than trying to plug it in back here to this equation. So our answer is 5.2, comma, 1.2. So one thing we noticed in our first two equations here, I'm going to erase part of this just so you can see the equations again, is that we had two equations. Even though this one doesn't look like an equation, we could graph y equals -9. We had two equations here. And in each one we had either y by itself or x by itself in one of the two equations, so we could plug it in to the other one. We plug this in for x. So here are our two equations. We need x by itself or y by itself. Now this bottom one already has x by itself, so we know x is equal to this whole piece. Now if you think of this one as a meal, and you don't want the x, you want the french fries instead, we're going to take whatever x is equal to, and we're going to plug it in its place. So I'm going to rewrite this first equation. It says 4x, but x is really 10 minus 6y. Put that in the place for x right there. Minus 2y equal to 14. All I did was take out this x and replace it with that whole piece so that I can solve it. I see parentheses, so I'm going to distribute. I have 4 and then 10 minus 6y. 4 times 10 is just 40. 4 times negative 6y, and 6 times 4 is 24, and it's negative 24y. And then don't forget the rest of your equation. Minus 2y equal to 14. So we're going to combine our like terms. Don't forget the negative. A negative 24 and a negative 2. They're all negatives. That's a negative 26y. The 40 out front still. And then we want to get y by itself, so get rid of this 40. I'm going to subtract 40. So those eliminate. I have negative 26y equal to, now if you're someone who's like, Ms. Calc, I don't want to take 14 minus 40, you can just plug it in your calculator. So negative 26. Or think different sign subtract, and there's more negatives. And then last, the opposite of multiplying is divide. I'm going to divide by negative 26. And we get y equal to, now a positive 26 over 26 is just 1. So remember, our answer is going to be a point, x comma y, because this is going to tell us where our two lines would cross if we were to graph them. Well, we're not going to graph them. We know y is at 1. We need to plug it back in. Plug 1 back into one of these equations. I like this bottom equation better because we already have x by itself, and that's what we're trying to find. So if we're trying to find x, it says take 10 and subtract 6 times y. And y is really a 1. We learned that, or we solved that over here. Well, 6 times 1 is just 6. So we have 10 minus 6. Well, 10 minus 6 is 4. So we know x has to be 4. The point 4, 1 is where our two lines would cross if we were to graph them. Alright, let's try another one by substitution. Later on, we're going to learn a third method, so it's important that we know the names of these equations, or how to solve them. Remember, we need x by itself or y by itself so we can substitute into the other equation. This one has y by itself, so anytime I see y, I'm going to replace it with 3x plus 2. So I'm going to rewrite this bottom equation. It says x plus 2y, and y is really this whole piece. 3x plus 2, all equal to 11. Again, all I did was take out y and replace it with whatever y was equal to. So I see parentheses again, I'm going to distribute. We have 2 and 3x plus 2. Well, 2 times 3 is 6, 6x. 2 times 2 is 4. So don't forget this 1x out front. You can put a 1 there. We have 1x plus 6x plus 4 equal to 11. So let's combine our like terms. 1x and 6x is 7x. And then getting towards the end here, subtract 4. Those eliminate. We have 7x equal to, well, 11 take away 4, 11, 10, 9, 8, 7. And then divide by 7 to get rid of that number out front. 7 over 7 is just 1. 7 goes into 7 one time. So my answer as a point or an ordered pair, x is 1. And then we need to plug it back into one of our two equations to find y. If y is already by itself in this top equation, I'm just going to use that one. It says y equals 3x, and x is a 1, plus 2. Well, 3 times 1 is 3, so 3 plus 2 is 5. So there's our point at which our two lines are going to cross if we were to graph them. We just did this without graphing them. Alright, last one here. It says which ordered pair is the solution of the system of linear equations. Remember, system meaning more than one equation or more than one line. So which ordered pair is the solution or the answer to the system of linear equations whose graph is shown? Well, our solution would be our answer to where they cross. So where do these 2 points cross? You can see right here. We need to figure out what point is that in terms of x and y. So be careful, you need to look at the scale. The scale goes by 2s. 2, 4, 6, 8. And same this way, 2, 4, 6, 8. So first x we're at 2, 4. And y we're up to 4. And in the middle between 4 and 6 would be 5. So the only point that matches is going to be answer E. A at 0, 2, that would be right here. That's not our answer. This one, 3.5, comma 0, that's like 1.5. That's right here. So where it's crossing the x-axis. So that would be the y-intercept, x-intercept not working. 5, 4, that's just backwards. That would be right here. 3, 3, that would be this point, closer. The only one that matches perfectly is the point 4, comma 5. So I know we went through things a little bit quickly. However, today we learned our second way of solving linear systems. First, we learned by graphing to figure out, hey, we have two lines. What point do they cross at? Today we did substitution, meaning we want x by itself or y by itself so we can plug it into the other equation. And we're going to do one more day of substitution before we learn our final way, which is solving by elimination to get our answer xy. Alright, your homework is using substitution. So remember, take your equation that has the letter all by itself and plug it in to the other equation. Take this, plug it into the bottom. Take this, plug it in to the bottom. Same thing. Then you do have one that is multiple choice. So you have 5 questions plus 1 multiple choice for homework.